Go. Namaste. This is Malik Arjuna, working as an assistant professor in Department of Mechanical Engineering, MIT, Mysore. Today we are in the laboratory, that is nothing but the energy laboratory. The energy laboratory has the code of 18MEL58. In this semester, this laboratory has a credit of 2. Today we will be studying on valve timing diagram. We are going to conduct the experiment on valve timing diagram. Before looking on to the experimental procedure or experimental conduction, let us try to understand few of the basic terms. We know based on the various aspects, the engines are classified into various categories. One such classification is based on number of strokes. The engines are classified into 4-stroke engines and 2-stroke engines. 4-stroke engines are those which will be making use of valves. 2-stroke engines are those which will be making use of ports. Our experiment name is valve timing diagram. Valves comes into picture only when we will be dealing with 4-stroke engines. That means I need to look onto one such 4-stroke engine. Here I will be looking on 4-stroke diesel engine. So my aim in the experiment is to draw the valve timing diagram for a given 4-stroke diesel engine. Operators that I am going to use are test rig only. Apart from that, I don't need anything. So let us try to understand the operation of 4-stroke petrol engine. This is the schematic sketch of a 4-stroke engine. Let us look onto the various components of an engine. This is spark plug, inlet valve, exhaust valve, top dead center, bottom dead center, cylinder, piston, this is connecting rod, this is crank, and this is perpendicular to the board is crankshaft, and this is the crankcase. So these are the various components of an engine. In 4-stroke engines, we have 4 different strokes such as suction, compression, power, as well as exhaust. So during these 4 strokes, what is the position of the piston that we need to look onto? So now let us start with the operation. Very initial stage is suction stroke. During the suction stroke, inlet valve is open and exhaust valve is closed. That means the piston starts to move from TDC to BDC, during which if it is a diesel engine, only air enters into the cylinder. If it is a petrol engine, charge, petrol as well as air enters into the cylinder. So during the suction stroke, piston moves from TDC to BDC. Once suction stroke ends, we will be moving on to the compression stroke, during which piston moves from BDC to TDC. During that time, both the valves are closed. That means mixture which is present over here or the air which is present over here will get compressed during the compression stroke. That is the second stroke. In the next stroke, the piston has to move from TDC to BDC. That stroke we have called it as power stroke, during which if it is a diesel engine, then we will be looking on to the initiation, the injection of the fuel into the engine cylinder. Since I have written a spark plug over here, this is the petrol engine in which the spark initiates the combustion. Therefore, combustion products forces the piston to move downwards. That is what is the power stroke to us, so that piston moves from TDC to BDC in a rapid fashion. Now, power stroke is over. The last stroke is the exhaust stroke, during which the exhaust valve has to open and inlet valve will be in a closed position. So the BDC to TDC momentum of the piston forces all the exhaust gases into the atmosphere. So this is how the operation occurs in a 4-stroke petrol engine. So now we need to look onto the valve timing. Valve opening and closing as well as the piston position. Theoretically, what we used to say is the valves will get opened as well as closed at the dead centers. This is what we used to say theoretically, but practically this will not happen. That we will look onto when we reach the valve timing diagram. So now during the suction stroke, inlet valve is open and exhaust valve is closed. During the compression stroke, both the valves are closed. During the power stroke, both the valves are closed. During the exhaust stroke, the outlet valve, I mean exhaust valve is open. This is what we are aware with respect to the theoretical background. So now let us conduct the experiment and then let us go through the few of the values. Okay, now here we are with the valve timing diagram experimental setup. Actually, by looking into the cross section of the engine, we can say this is a 4-stroke diesel engine cross section. Why I have identified this? This is the fuel injector, so because of that I can say this is the diesel engine, and I am seeing the valves over here, so because of that I can say this is the 4-stroke engine. So finally this is the cross section of 4-stroke diesel engine. Let us look onto the various parts which are present over there. This is the piston, this is the cylinder portion, and this is the connecting rod, and these cam mechanisms which are present over here, and this is the crankshaft, and to the crankshaft we have attached flywheel. So these are the various parts I will be looking into along with valves. On the right side I have inlet valve, on the left side I have exhaust valve. Now my job is to looking into the opening and closing of these two valves for various strokes. So that is what is my job now. So before conducting the experiment, let us go through few theory points. In theory, what we used to say is, in 4-stroke engines, we have 4 different strokes such as suction, compression, power and exhaust. During all these strokes, we need to look onto the position of the piston. During the suction stroke, piston will be at top dead center. During the suction stroke, piston will be at top dead center, and during the starting of the compression stroke, the piston will be at bottom dead center, and during the starting of the power stroke, again the piston will be at top dead center, and during the starting of the exhaust stroke, piston will be at bottom dead center. So these are the various positions of pistons at various strokes. So now what theory says is, during the suction stroke, the inlet valve is opened and the outlet valve, I mean exhaust valve, is closed. During suction stroke, the charge enter into the cylinder in case of petrol engine, whereas in case of diesel engine, only air enters into the cylinder till piston reaches bottom dead center. Once the suction is completed, the compression stroke starts from the movement of the piston from BDC. So during that time, both the valves are closed. I mean inlet as well as exhaust valves are closed. Now compression stroke happens. During the compression stroke, piston moves from BDC to TDC. Next, power stroke has to happen. Well, during the power stroke, both the valves are closed and the piston moves from TDC to BDC. Then now exhaust stroke has to happen. During the exhaust stroke, the exhaust valve is opened and inlet valve is closed, and piston moves from BDC to TDC. So this is what we theoretically say, and this is what is the piston's position during the various strokes of the engine. So this is how we express the position of the piston with respect to the cylinder at various strokes. But practically this will not happen. What I mean to say is, exactly at the dead centers, the valves are not going to open and the valves are not going to close. In order to look into those precise values of valve opening and closing, we are performing this particular experiment. So now our aim, what is our aim in this experiment? To precisely look into the valve timing, I mean valve opening as well as valve closing for various operations that are involved in the 4-stroke engine. So now let us conduct the experiment. Initially, let us look on to the various valves which are present over here. So these two are the valves which are available with us. So right hand side I have the inlet valve, left hand side I have the exhaust valve. In the normal operation, what we can expect is the fuel burns inside the engine cylinder and it provides the energy to the piston. Piston moves within the engine cylinder in a vertical fashion, I mean reciprocates inside the cylinder, and that reciprocating energy, I mean reciprocating motion is supplied onto the flywheel through the crankshaft. Here it is the crankshaft. So that reciprocating motion of the piston is converted into rotary motion of the shaft. So now the shaft is attached to the flywheel. So now in this experiment we are not burning any fuel over here, but we need to rotate the flywheel. I mean we need to rotate the crankshaft. Thereby we will be giving the reciprocating motion to the piston. For that purpose we need to manually provide the energy to the flywheel so that I can look onto the opening and closing of valves for various strokes. So now my first job is to look onto the flywheel. So this is the flywheel that is available with us, and we have a measuring tape which is mounted on the flywheel. So this measuring tape is mounted on the flywheel to look onto the circumference of the flywheel as well as to look onto TDC as well as BDC's position. So that is what is the purpose of providing the tape on the flywheel. So if we want to conduct the experiment, we need to be very careful. So let us start the experiment from first stroke, which is nothing but the suction stroke itself. So I need to adjust the flywheel in such a way that for the suction stroke, the piston will be at TDC. Let us adjust the flywheel. This flywheel needs to be given the motion in from this side. I have to give the motion in clockwise direction. If I look from the engine side, it is an anti-clockwise direction. If I look from this side, I have to give a motion in a clockwise direction so that I can perform the various operations manually. So I will adjust the things in such a way that I will be at suction stroke now. Before that, make sure this is the point, this is the TDC point, and exactly half a rotation, I mean 180-degree rotation will give us BDC point. This is the BDC point, and here we have a pointer. So with the help of this pointer, we will be looking on to positions, TDC as well as BDC. This is the pointer which is available to us. So with respect to this, we will be fixing TDC as well as BDC. So now I will adjust the flywheel so that I will be in suction stroke. Okay, now if you see into the piston's position, piston is exactly at TDC. That means only two options is possible when piston is at TDC. Either I will be at suction stroke or I will be at power stroke. By the adjustment, it is very clear that I am at suction stroke. On this side, the pointer is matching with the TDC's position. Now I will give the clockwise rotation to the flywheel so that valve opening and closing will be look up, or we can see the valve opening and closing. I am giving the rotation manually. Piston is moving downwards, you can see over there. That means suction is happening. Here, if you observe, inlet valve is opening. Inlet valve has a movement over here. You can see that. Now piston is moving in an upward direction. Still the inlet valve is open. Okay, so now at this time, at this crank angle, if you clearly observe, the movement of the inlet valve is stopped. So this is the one point that I was looking for. At what crank angle the movement of the inlet valve stops? That is what is the question. If you look onto the piston's position, piston has started to move from TDC to BDC, and again from BDC to TDC it has lifted a little bit, in the sense inlet valve has been closed after piston reaches the BDC. I mean, the next stroke, what is the next stroke? Which is nothing but the compression stroke. Part of a compression stroke is already has happened. During that time, the inlet valve is getting closed. That means one of the value is fixed now. The value or the thing is nothing but inlet valve closes after the BDC. If you want the reading on the flywheel, please come on to the side. If you clearly look onto the mark over here, this is the BDC mark. Below this, it is the before BDC. After this, this is the after BDC. So I have crossed the BDC by this much readings. That means inlet valve has been closed after BDC. So one of the value is fixed now. Let us continue the operation. Now I will continue the rotation that I am giving to the flywheel. Inlet valve is not moving. Exhaust valve is also not moving. Now, if you clearly observe the piston again reaches the TDC. That means two of the operations are over. First one is suction and the second one is compression. Both operations are over. Now, fuel injector injects the fuel, and fuel injector atomizes the fuel and inject it into the engine cylinder. This fuel mixes with the air and starts to burn. Because of that, power starts to generate. That burnt gases applies the pressure on the piston. Now piston again starts to move downwards, in the sense power stroke is being happening. During that time also both the valves are closed. I am giving the momentum now. Now this is the inlet and this is the exhaust valve. If you clearly observe the exhaust valve is getting opened. This is getting opened, but still piston has not reached BDC. Piston hasn't reached BDC yet. I can show you that. Now you can look on to that. Piston hasn't reached BDC completely. That can be seen by the piston movement, or on the reading also you can observe it. The reading hasn't touched the BDC mark yet. So second reading I am available with now is exhaust valve opens before piston reaches BDC. That means before the end of the power stroke, the exhaust valve is going to open. That is what is the second reading that I have to look onto. I will continue the momentum that I am giving to the flywheel. Exhaust valve is getting opened. Now piston is coming upwards from the BDC. Exhaust valve is opening still. Still exhaust valve is having a movement over here. Exhaust valve has not closed yet. Now I am performing a exhaust stroke because piston is moving in a upward direction. Now if you clearly observe the inlet valve, please observe the inlet valve. Inlet valve is getting opened. Still piston has not reached the TDC. That means still the exhaust stroke has not completed. Before that, the inlet valve is getting opened. I am ready with one more reading now, which is nothing but inlet valve opening before the piston reaches the TDC. So this is what is the place, crank angle at which the inlet valve is getting opened. So this is what is the reading that I can look on the scale. Before piston reaches the TDC, inlet valve is getting opened. Now I will continue the momentum to the flywheel because still exhaust valve is open. So I am continuing the momentum. Exhaust valve stops its momentum now. Now if you clearly look onto the piston has started the second cycle. That means second cycle's first stroke is being happening. What is that first stroke? Which is nothing but suction stroke. Second cycle's suction stroke is happening. During that time, the exhaust valve getting closed. That means I have I have one more reading now, that is nothing but closing of exhaust valve. The exhaust valve is getting closed after TDC. I mean, after reaching the TDC, piston is moving towards downwards. During that time, the exhaust valve is getting closed. So all the four values I am available with now. Let me clear the readings now. Very first thing was what I have seen into inlet valve closing. Inlet valve closing happens after piston reaches the VDC. I mean during the starting of the compression stroke, inlet valve closes. Second reading is opening of the exhaust valve. Opening of the exhaust valve happens before piston performs the complete power stroke. That means before piston reaches the BDC, the exhaust valve opens. That is the second reading. The third reading is opening of the inlet valve. Before piston completes the exhaust stroke, inlet valve gets opened. So the reading is before TDC, exhaust inlet valve is getting opened, and the last reading is closing of the exhaust valve. Exhaust valve will get closed in the next cycle's first performance, first operation, which is nothing but suction. So the readings are very clear now. Inlet valve opens before piston reaches TDC. Exhaust valve closes after TDC. Inlet valve closes after BDC, and exhaust valve opens before BDC. So these are the various readings that I have to look on. So this is what is the values that I have to take from the experiment. Here I have the tabulated values with me from the experiment. So let us look on to the various calculation that I have to go through. Inlet valve opening. IVO stands for inlet valve opening, inlet valve closing, exhaust valve opening, exhaust valve closing. From experiment conduction, we have come to know that the valves are not getting opened and not getting closed exactly at dead centers. That means there is a little variation present in opening and closing of the valves. So that has been written over here. Very first thing is the inlet valve opening before TDC. That means inlet valve is not exactly getting opened at the TDC, but before piston reaches the TDC, inlet valve is getting opened. That reading what we have taken as 1.9 centimeters before TDC. This 1.9 centimeter has been converted into degrees by this arrangement. 125. What is this 125? This is length of the circumference of flywheel. That is what we have observed while conducting the experiment, which is 125 centimeters. If we divide the actual measured value by 125 centimeters and multiply that with the 360 degree, I mean one complete rotation of the flywheel, we will get the actual opening of the inlet valve in terms of crank angle, in terms of degree. Inlet valve opens before TDC at a value of 5.472 degrees. Next thing is inlet valve closes after BDC. Here also inlet valve is not closing exactly at dead center. It is closing after BDC. The value what we have taken from the experiment is 10.8. If we multiply the thing with 360 degree and divide the value by 125, the degree comes out to be 31.104 degrees. That is what is the angle with which the inlet valve closes after BDC. Next thing is exhaust valve opening before BDC. That means exhaust valve opens before piston reaches BDC. The value what we have taken from the experiment is 13.4. If we divide that by circumference length and multiply that by 360 degree, we will get the crank angle, which is nothing but 38.595 degrees before BDC. And the last thing is exhaust valve closes after TDC. The value what we have taken is 1.8. I have divided that by circumference length and multiplied that by 360 degrees. So the value what I have got is 5.184 degree after TDC. So this is what is the observation as well as the calculation what we have made from the experiment. So now if we plot the valve timing diagram, we will clearly understand what exactly is happening in the engine, how precisely the valves are getting closed and opened. That we will look from the valve timing diagram. Let us look on to the valve timing diagram. The vertical line what I have written is a reference line. At the top I will have TDC, top dead center. At the bottom I will have BDC, bottom dead center. So now very first thing is inlet valve opens before TDC. So this side what is there on the left hand side of TDC is before. What is there on the right hand side is after. So here it is with respect to BDC, this is before and this is after. So now please look on to the reading. Inlet valve opens before TDC. Before TDC in the sense to the left of the TDC. What is the angle? 5.472 degrees. So this is the inlet valve opening with respect to TDC. Before TDC, inlet valve is opening and this angle is nothing but 5.472 degrees. I have expressed that with respect to the TDC. That is what is the inlet valve opening. Next thing is inlet valve closing. After BDC, the value is 31.104 degrees. After this is BDC, this is after BDC. So from BDC, this is the angle at which inlet valve closes. So with respect to BDC, this is the angle which is nothing but 31.104 degree. For this angle, the inlet valve is getting closed with respect to the BDC. Next thing is inlet valve opening before BDC. Exhaust valve opening before BDC. The value, this is what is the value. Let us look on to the opening of the exhaust valve over there before BDC. This is BDC, this is before thing. So exhaust valve is getting opened before BDC. So this is the angle for which exhaust valve is getting opened. The angle value is 38.595 degree before BDC. And the next and final thing is the exhaust valve closes after TDC. That means after TDC, exhaust valve is going to close, which is the value is nothing but 5.184 degree. Please search for this case after TDC. So this is TDC. After TDC is this. So after TDC, the exhaust valve is going to close. What is this angle? That angle is nothing but 5.184 degrees. So this is what is the valve timing diagram, which says that the opening and closing of valves at various locations precisely. If we clearly observe the valve timing diagram, it is very clear that valves are not getting opened and closed exactly at dead centers. So that is what we have observed from this sketch. Next thing is why it is why it is happening in such a format. Why the valves are not getting closed and opened exactly at dead centers. That is what is the next question. So if we look on to the inlet valve opening, inlet valve is not opening exactly at TDC. Why it is opening before TDC? That is the question. Because in case of high-speed engines, we need to provide the high-speed engines with lot of charge. In case of petrol engine, so in order to inject the lot of charge, I mean huge amount of mixture into the engine cylinder, this inlet valve opens before TDC. When the engine is running at a lower speed, in order to reduce the compression ratio, this huge amount of charge which is injected into the cylinder helps. So because of that, the inlet valve is made open in such a way that before TDC it is made to open. So that is what is the reason for that. Now if we look on to the exhaust valve opening, exhaust valve opens before BDC. That means the exhaust valve is getting opened before piston reaches the BDC. Why it is so? Since the power stroke hasn't been completed, complete power stroke has not happened, but the exhaust valve is opening before it reaches the BDC, because the part of the pressure that has to be applied onto the piston by the exhaust gases will not be so applying the pressure on piston. So we will be compromising over here so that this pressure can be utilized in sending the burnt gases out of the exhaust valve. So because of that, exhaust valve gets opens before it reaches the BDC, and then exhaust valve closes after TDC. Why exhaust valve closes after TDC? Because once TDC, piston reaches the TDC, one complete cycle is over and next cycle starts. During the next cycle, the fresh incoming charge can have the responsibility of remaining burnt gases to send out of the engine cylinder, so that no combustion products of the previous cycle will be present inside the engine cylinder. That such an arrangement is made at this particular case. Because of that, exhaust valve closes after TDC. So for every timing we have a particular reason. So that is what is there behind opening and closing. One another aspect, very important aspect that we need to look onto here is valve overlapping. Valve overlapping is nothing but the opening of both the valves simultaneously for a precise amount of timing. For precise amount of timing, both the valves are opened. That particular crank angle, that particular period for which both the valves are opened is called as the valve overlapping. If you clearly look onto this, here both inlet as well as the exhaust valves are open. So this period for which both the valves are open are called as valve overlap. The process is nothing but the valve overlapping phenomenon. So that is the valve overlapping. Now finally, if we look onto the overall angle for which the inlet valve is opened, if I check onto that, this line shows us the overall angle for which the inlet valve is opened. Now if I look onto the overall angle for which exhaust valve is opened, from here it gets started and at this place it is going to end. From here to here the exhaust valve is open. So this is the overall angle for which the inlet valve is open, and this is the overall angle for which exhaust valve is open. So this is what is related to the valve timing diagram. So finally we can say that valve timing diagram is a diagram which precisely gives us the opening and closing of valves with respect to the piston's position. This is what is related to the calculation part as well as the drawing the valve timing diagram. In the next part, we will have a few of the important Viva questions. These are the few important Viva questions we have in this experiment. Thank you.